So I'm going to talk about how Elixir helped us scale video API for the Olympics. I'm going to talk about me first. I have 10 years experience in programming, and I love that. I graduated in computer science in Brazil. I'm a former software engineer at Globo, and currently I work here at Shopify. This is my GitHub and my Twitter, if somebody wants to follow me. And fun fact, I actually have deployed Elixir way before Phoenix exists, so I know a little bit about Elixir. So briefly, I'm going to talk about the problem that we solved at Globo. Then the refactor that we had to do, and after the refactor, finally Elixir rewrite, and of course the thoughts about rewrite our code in Elixir. For somebody that doesn't know what Globo is actually the largest media company in Latin America. It owns newspapers, television, makes movies, so it's a really huge company. And Globo had a project that called Globo Play. That's basically all its videos broadcasting online via streaming. So this video has a solution that is Video API. In that Video API has a feature that is it records the usage of the video for each user. So once I'm logged in the system on the website, it pulls our servers every 10 seconds to capture our information, like, for example, how much I watched a specific video. So if I come back to the website, I can continue watching the video when web stopped, and also I can mark some videos as favorites. This is an example of the UI. I can watch the video and just give it a heart, then I can watch it later. And if I stopped watching a video, I just can continue watching right where I stopped. The Video API itself is built on top of Ruby on Rails in 2012, and is a really well-done API, like one of the most well-done APIs that I haven't seen. And it was built for another product that was Globo TV, that's dead. But we migrated later that same solution for two products, that was Globo Play and Globo Site Play. Globo Play is basically every content that was transmitted via broadcast, and Globo Site Play is like a premium content that's transmitted only via cable, and of course you have to pay for it. So we are using that to save the information of the user across all devices, mobile apps, websites, desktops, and of course phones. At first, the solution that was built on top of Rails we deployed that solution using only two bare metal machines. Those bare metal machines, servers, each have 24 CPUs and 64 gigas. Of course, because we are scaling so fast, we doubled our size and end up with 4 bare metal CPUs machines. But something is happening in Brazil. That was the Olympics, and we were really afraid that our video API could not handle all those requests, because we knew you were going to grill. Then we was afraid, because we just can't spawn physical machines every time. You can buy at the market bare metal servers and just install yourself. So our first rewrite of the ecosystem was to use the API AAS that's called Suru. It's like Heroku, but open source. Global itself built that platform as a service, and it basically builds Docker containers to scale across multiple servers. So how that Suru works in a nutshell? You have a source code, you push the source code to a Git origin, it detects that you're pushing a code for that origin, then it builds the code. It builds the code in the container. Of course, in the project, we specify how it's going to be built that code. Then once the Docker is built, the Docker is stored into a CDN. Then Suru just managed to push that Docker into a pool of machines. But it's not just a few machines, like a huge pool of machines. It's because there's so many machines Suru can push, it manages what are the buried machines for each system. And of course, the same server, we run multiple applications. We can run Ruby, we can run Python, Go, even Node. So basically, we prepared our system to use Suru. And Suru, you can define the metrics that say if I hit some CPU during that time, it scales up, or memory, or throughput. Just scales up because that container is not good enough. So we need more containers to handle the solutions. Each container has only one CPU and 2 gig of memory. So our first solution, we deployed like 4 containers, and we arranged the metrics to see how it would scale. So it spawned some containers, some more containers, and some more containers. In the end, we had 93 containers. Yeah, it's a lot, but if you think about that, it's basically the same of having 4 bare metal machines at the time. But we are really confident with that solution because overall, we know that Suru could scale more. Suru could scale to 2,000 containers if it was the case. Not 2,200, sorry, English. But in the end, we are not so secure about the solution. We knew that we could do more. So we decided to revisit what we did before. So basically, there was this route or API that was a post route that was responsible for 80% of the API calls. This route basically wrote directly on Mongo after fetching data from external APIs, video APIs from other partners from Global. And also we need to process some things in parallel. So we had a REST application that was a separate application. So we used Redis to enqueue our messages and process that later. Then we decided to reroute on that route that was really critical in Elixir. Overall, Elixir has similar tools to Ruby, like they had Mix that's really equivalent to Bundler and Rake. Also, there's a really popular framework that helps us developing really fast, that's Phoenix. And of course, there's OTP. OTP basically provides parallelism solutions really out of the box, like Gen servers. The team was a little afraid just because we had to change the paradigm. We used to write a lot of object-oriented code. Now we had to write functional. Then after the rewrite, we had that system. Basically, all our post requests came directly into Elixir backend. We killed the reds. We had reds to cache and also reds to kill background jobs. We were starting to use Progeny servers, that are a solution built directly on Erlang VM. And of course, we are using MongoDB. So basically, just to hear out that one out, we used a library for cache called CacheX that uses a distributed DB that is also built on top of Erlang VM called ETS. We had a really bad problem with the Mongo driver, mostly because the Mongo driver we had at the time didn't support properly replica setting. So we had to fork that Mongo driver and to make it support replica set for MongoDB. That's the really bad problem part of early adopting stuff. And also, we really love New Relic at Global. We use New Relic for everything, but there's no solution ready for New Relic. So we had to use a Erlang library, basically to log our metrics into Logstash and Grafana. And of course, we removed 20 Docker containers aimed just for background job. And it was built at the time into Elixir 132. Erlang 19, Phoenix 1.0.1. This is the fun solution. Basically, when a request comes from the internet, passed through reverse proxy, if it's a post to update the user profile, goes to Elixir. If everything else goes to old Ruby on Rails API. Of course, let's compare some metrics. Despite the fact that we are using a lot of our infrastructure to roast our Ruby on Rails, the API was fast enough. Like 40 milliseconds is really fast. So you are proud of that number. We were not having a really high throughput, like 50,000. But when you compare to Elixir number, we jumped from 40 milliseconds to 4 milliseconds. It's 10 times faster, basically. And the percentiles was kind of strange because it was like 40 milliseconds, like the percentile, 99 percentile was the actually average response of the Ruby API. And of course, we had a larger throughput when that screenshot was taken, because for the Olympics, we were getting a lot more traffic. So we had a really component reduction. That image that I showed before, we reduced it from 93 Docker containers on their first API implementation to only 33, which 30 was just for the Ruby on Rails route. And to handle that heavy route with a lot of throughputs, we had only 3 containers building on Elixir with 10 times faster API response. We had a total reduction of 62 containers in production. So we reduced the containers to handle the Olympics that we are afraid of. So, not afraid anymore. That solution is one solution that the team did and we were really proud about. Today, everything's changed, of course. That part of the API is totally built on top of Elixir and really changes the database to use MySQL because of that problem with the Mongo driver. We decided to try MySQL and we figure out that my SQL is really hard enough, fast enough for the problem. I want to thank my two former co-workers that was the project originally, that's Emerson Leite and Luis Filho, and also thank Globo.com, because I believe that Globo.com is really amazing company that invests on the talents, and they permitted us to do that in basically 3 months, which was crazy. And also thank Shopify to support open source, support the Elixir community. It's really amazing. And if you guys want to know more about this case, Emerson had wrote 2 blog posts about that. One, he basically make a summary. Then the second one, he goes in details about what was the game, what he didn't like, and what was the motivation. Thank you.